What I'm going to talk about today is taking that technology and putting it to an aircraft, which in my mind is almost rocket science. I'm a retired Army officer, political scientist, no way an engineer. So when you get real hard questions, I'll defer to others. Today, I'd like to talk to you briefly about the Boomerang Airborne Tactical Sensor System. As I mentioned, its growth is from the thousands of systems it put in theater, BBN put in theater for Boomerang, both hostile fire on vehicles and fixed site, which did extremely well. BBN in and of itself is the world's leader in acoustic the use of acoustic, grown from the JFK tapes for the assassination and the Watergate tapes. So we could go ad nauseum if you're interested in BBN history. Next slide. The threat detection for rotary wing. So imagine, as Bob correctly put, being in a vehicle trying to figure out if something's firing at you. It is 8 times as hard in an aircraft because you have so many other noises around you to have the slightest of clue that you're being fired on, especially when you're the JMO in the back, which I've done hundreds of times, having any idea that somebody's firing at you. So what BBN has been able to do, using an array of sensors around the aircraft, take out the noise from the rotor and also take out the outgoing fire if the aircraft is equipped with any kind of firing mechanism. So it can truly tell where the shooter is coming from, the direction and class of weapon coming at them, which to my mind is pretty good essay for if you're on an aircraft. Next slide. A couple things that we want to make sure we highlight, that BATS, the Boomerang Airborne Tactical Sensor System, is a COTS item. It's developed. It's been proven out on both and flown on both the 47 and the 60. Been shot at with a greater than 90% reliability of detection. And I know I'll get some looks, but that's okay. And what makes the BBN approach a little bit different and patented is the use of the distributed array of acoustic sensors that connects to a CPU that allows for greater fidelity in the algorithm to figure it out, which is pretty neat. They're looking for 2 things as it comes out: the shock wave from the passing projectiles and the muzzle blast, when the muzzle blast is not hidden from the noise of the aircraft. And from that, they can determine and provide an audio and a visual alert to the crew of the location of the shooter and the class of weapon. And so that goes a long way in telling what's happening around an aircraft when an aircraft, they're busy flying, usually head down without a clue. BATS is TRL level 8, and again, it follows the lineage of the tens of thousands of systems they put in. The high probability of detection of small arms up to AAA threats is not, it doesn't have anything to do with the speed or elevation of the aircraft. It's not dependent, and it can determine. Next slide. I put these in there being a Tradoshian myself, and this is the de jour that General McMaster's is using to measure and quantify things. Warfighter Challenge. Like most new capabilities, you can almost fit it into any bucket you want, and BATS does that. There are several things from increased SA, location that it fits in and does a good, didn't like what I was, does a good job at going across multiple warfighter challenges. Next. All right, a little bit of the theory, and I'll rapidly leave my ability to explain, but I will do my best. And we do have engineers here if you want to ask a specific question. Again, the system detects the bullet shock wave as it passes the sensors. The more sensors it passes, the better. And I'll get into it in a minute. It needs greater than 5. The detection of the muzzle blast signal, when available and not passed by the aircraft, allows it, when coupled with the shock wave, to give the location and class of the weapon, and all based on the time of arrival of the bullet as it passes, or whatever, as it passes the sensor. Next slide. Again, the BBN approach is patented as an acoustic array. It measures the shockwaves arrivals at numerous sensors, requires greater than 5, as it was explained to me earlier. And again, I'm a political scientist, that in basic algebra, in order to solve for 1, you need up to 5, and then you can work a mathematical equation. To me, that's flux capacitation. But that being said, I get it. I've seen it work, and it works very well. What I think is neat is the determination of threat. So it'll enable either somebody in the back of the aircraft or the aircraft crew itself to know that it's a small, medium, or large caliber up to AAA that's firing at them, so they can determine what the next course of action is when it goes in. Next. As in anything, when you deal with an aircraft, the weight is critical. Consists of 2 parts: the CPU, or the processor, which is roughly 9 pounds, and then the sensors in and of themselves, which is 3/4 of a pound, and then the cabling. So if we took generic weights based on the size of the aircraft, the amount of sensors, a 60, you're adding roughly 40 pounds of weight to the aircraft, and a 47, you're adding roughly 60 pounds of aircraft. And again, it's aircraft dependent. Smaller the aircraft, less number of sensors, as long as it has greater than 5 to increase the fidelity. You have less cabling, less weight, and we go from there. Next. The BBN engineers have done a very, very, very good job at the use of modeling and simulation. They know when they go into an aircraft, based on what they've assessed, roughly how many sensors and sensor placement it's going to take, and then they use removable surface mounted sensors to test that data to prove out what they did, and they've done it very, very well. It's flown in test multiple times with extremely accurate results. Afterwards, if anybody wants to ask me who the customer is, or if you're a government guy who you can get in touch with, I'll be happy to tell you. Next. Finally, points of contact on the industry side. If you have additional questions, you can contact Chris Connors up there, or you can contact myself, or I can put you directly in touch with the BBN Raytheon guys. Again, I appreciate your time. I do believe in the Boomerang Airborne Tactical Sensor System. I think it's making a difference. Luckily, the threat has gone down some in Afghanistan. Nobody's being shot at. But if so, maybe in the near future we'll have an aircraft there that can measure and determine the results.